Everyone, my name is Brian Langbecker, and I'm one of the solution architects here at Honeycomb. And we're going to talk about distributed tracing. What I want you, as part of these slides and the demonstration, that walk away with a basic understanding so you can answer the question, what the heck is distributed tracing? What are the various questions it tends to solve? How does Honeycomb go about doing it? And why is it important? So the first thing is, let's talk about the definition of what distributed tracing is. Now, the first one is a pretty academic one. Understanding the flow and the life cycle of a unit of work, that's one of the key things, performed in multiple pieces or steps across components in a distributed system. Kind of a complicated definition, right? Simpler one is, it tells the story of a complete unit of work in your system. And what are three of the most common questions that you're going to get when you have a distributed trace going on? The first one is, why is this thing slow? What do we mean by this unit of work? Say we're at the bottom. Earlier in the day, we're going along great, and all of a sudden, things get really, really slow. We cross over our P90 threshold, really bad performance. People are complaining. That's one of the common questions. We're going to cover that in the demo. Next one is, I'm a new developer. I've joined the company. I don't really understand where everything is going on. I can look at documentation, or I can look at a live trace, this sort of gray box. You've probably heard the term white box, where I can see everything inside it, black, where I understand nothing about it. I've got this gray one. I know it's an API. I know I get a response, but what does this thing do? Distributed tracing is ideal for understanding that. And the last really typical common question is, when things are failing big time and error rates are spiking through the roof, what is going on? We want to dive into traces that have these errors and understand what's going on in the system. So what have we covered here? Honeycomb helps you answer, and so does distributed tracing. Why is this thing slow, this unit of work? What does this thing even do? And then why are things failing? So let's look at a few slides that have distributed traces in them, and then we're going to jump into a live demo. So I don't want you to get overwhelmed at looking at this. If you've never seen this before, it can be quite overwhelming. But let's look at this from a high-level perspective. There's 4 or 5 services you can see in the second column from the left. The first one, commonly known as the root span, is taking about 3.23 seconds. And if you look over at the side, and I'll orient you around heat maps at Honeycomb, the bar at the bottom is the baseline, and we're way out of the baseline that's going on. And as we go through here, in this 3 seconds, we start out placing an order, we get a cart, we get a product, we go check some things out across multiple services in a system. This is a distributed trace, and this is what we're going to do in a demo. But before we jump in, I want to orient you on some terminology here. The first terminology is the root span. It's the very first portion of a trace. It's a span. It's that row information. Every other row in the system is just a span, but this is the root. This is where everything starts. Next, we have the service name, the individual services that make up this tracing journey. We have the name of the components. What is the name, the function, like a select statement or a place order that's going on? And then over here, to identify each and every one of these rows, we have a span ID and we have a trace ID. Now, we have more data that's common to it. We got to know when the thing started. We have to know how long the thing took. In the top root span, it took about 3.24 seconds. We need to know where we are within the position of this graph. There's an ID I'm not showing here, but you'll see it later, called the parent ID. But these are key things to understand. Who's my service? What's my name? What's my root span? Trace ID? All those things. If you keep hearing those things, that helps me constitute and build a graph in the system. So let's jump into a live demo. So when you instrument your systems with Honeycomb, what do I mean by instrumentation? If that hasn't been covered already, it's typically an SDK or library you add into your code that then automatically sends over these spans of information, these traces, and with that, you're able to understand things like the total requests that are going on in the system, the error rate, and the latency, aka how fast I'm going on, what kind of errors I'm dealing with, and how slow it's going on. Now, in this demo that I'm running here, you'll notice this little bar going here. This is a build. And the minute I released a build recently, shortly thereafter, I got a spike in latency. And that's what we're going to look at a trace to discover what the heck is going on in my system. So I'm going to click on this. Again, as I oriented you, we love our heat maps throughout the system. We believe this really describes what's going on. With this one, I can see as I go up higher, things are getting slower. If things are farther down, they're faster. I can see where activity is busy. Now let's jump into a trace. Now if I click on tracing, I'm going to see a list of my traces from the fastest ones to the slowest ones. I can see my root service. This is where it entered the system. I can see a name of it. This is a fictitious ticket booking website. I can see the duration. I can see the number of spans. Now I could click on this. It's the top one right there. Or what I can do is I can jump in to this one that's right here within the system here. And oh my gosh, this is an excellent one because not only are we have latency problems, we even see an error rate on this one. So let's look at the very top of this one that's going on in the system that I picked here. I can see based on the heat map, this is normally really, really fast. I'm running really, really slow. I can see within the system itself that's going down in the system here. These are all running really, really fast, very normal. You're kind of like, we know exactly where the problem is, Brian. The error is calling it out clearly. But let's jump down into this area here. And I can see that this normally runs really, really fast. But what is going on down here in the system, it's running really slow. Why is that the case? If you're looking at the screen, you're like, it's obvious, Brian. You keep calling the SQL statements all the time. Why am I calling them? It's a simple SQL statement. Let's look at, is it the SQL? Everybody likes to blame databases for the problem, but if we look over in the heat map here, guess what? Every one of these calls is having an issue within the system here. Now, we had an error up here. My deadline expired on the thing. That's not really the big source of the thing. Why is this thing slow? It's not the error message why it's slow. That's just an error message. But that was our third scenario, which is what's going on. I'm getting deadlines expired. I'm making too many. If I look down here, way too many SQL calls. Why am I doing that? Well, because in this ticket booking service, I've introduced the famous N+1 problem, a fancy name for an anti-pattern, where I built this system out assuming that we'd only buy 2 tickets at a time, 4 tickets at a time, 6 tickets at a time. And we recently introduced a feature in the system where it allowed people to do bulk purchases. This user over here, 2019, is one of our bulk users. Now and how did I notice that here? Well, let's look at the data that's here. We got timestamps, database queries. This is all out of the box information. But because I decorated it with additional attribute information, a user ID, maybe an email address, whatever I want to add in, Honeycomb can take it. We have a concept of white events. I'm able to clearly see this is, and I'm like, what the heck is it with user 2109? Well, I happen to know. In the system, user 20109 is one of our heavy users, and they're using a new set of features. And clearly, when we added a new feature, nobody bothered to realize that we didn't allow you to bulk order tickets. So as he's looking through, he's getting his tickets and doing activities throughout this system. So this is the power all in one UI and Honeycomb. We handle 3 solutions here. We handled one, where is it slow at? Well, it's in this backend service. It's not the gateway. Gateway looks like it's slow. No, gateway is dependent on the backend service. We handle the other question, which is if I'm a brand new developer and I had never seen this before, guess what? I now understand this is composed of a whole bunch of services in the system here in this one, and we can clearly see that there is an error going on. This error happens once in a while in the system. If I were to pull out here, just for the sake, and maybe pick a different one here, I don't have an error there. So the error is really not a critical error. Notice I didn't have a set of spiking errors at the time I was looking at things. So we answered those 3 questions. Now, without distributed tracing, how would I answer this? Well, I'd probably look at this and say, okay, that thing's really slow. Maybe it's that fault. I wouldn't know it's this fault unless I understood the code fairly well. And then I would look over saying, what's going on with my backend service? And I would have to construct all these things together. So that is the power of distributed tracing. So what have we answered? What is distributed tracing? Looking at this complete unit of work. What are some questions it solves? Slow, understanding the system, my errors that are going on. Why is it important? Because if you don't have something like this, how do you know what's going on with your system? You're stuck looking at metrics behind the scenes and guessing. And the cool part is we isolated and said this, in the case of this one, certain users are having very, very bad performance. So I want to thank you for listening to my discussion. Hopefully you now have a basic and a little more in the basic one. You're able to understand, hey, I've got trace fields. I've got trace IDs that are going. Let's go down to this one. I've got parent IDs. This is how it's built. I know about durations. I know when it starts. That's how I can see this visualization. Wanted to thank you for your time and look forward to meeting you in the future.